Hi, grade 6. It is day 19. We're at lesson 9-6A, page 392, numbers 3 through 13, all of them. Before we get started, please pause this in a few seconds and read page 391 carefully, then come back to the video and we'll give you some help on how to approach some of these problems for today. Thank you. Okay, welcome back. Problem 3 says the following. Determine whether using a spinner with 4 equal sections is a good way to answer a 5-question multiple choice quiz, and each question has a choice of A, B, C, or D. And then explain. So this is similar to the question that is on the previous page that you were supposed to have just read. Let's go through and talk about this a little bit. Let's imagine that this is your test sheet and these are the answers to problems 1, 2, 3, 4, and 5, but you don't actually know the answers yet. And your job is to figure out for problem 1, is the correct answer A, B, C, or D? For problem 2, is the correct answer A, B, C, and D? And so on through the 5 questions. Problem 3 says, use something like this, a spinner that has A, B, C, and D on it, to try to see if the spinner can come up with the right answers. So that's what we're going to do right now. Let's see what answers we get if we use a spinner. For problem 1, I get an answer of D. For problem 2, I get an answer of D. For problem 3, I get an answer of B, boy. For problem 4, I get an answer of A, apple. And for problem 5, I get an answer of A, apple. Let's see how we did. No, yes, here's a correct answer. Here's a correct answer. Here's a correct answer. Uh-oh. We only got correct answers 3 out of 5 times. On a 5-question quiz, that's not the greatest score possible there, obviously. Let's try it again. Let's start over and let's spin the spinner and see if the second time we can come up with better answers. On my first spin, I get a B, boy. On my second spin, I get a B, boy. On my third spin for question 3, I get a D, dog. On my fourth spin, I get an A, apple. And on my 5th spin, I get a D, dog. Oh boy. It only looks like right here, question 4 is the only one we get correct when we compare it to the answer key. Let's try it once more. Erase all those previous answers. And let's see what happens if we do it one more time. For question number 1, my spinner says C, cat. For question 2, my spinner says A, apple. For question 3, my spinner says A, apple. For question 4, my spinner says B, boy. And for question 5, my spinner says A, apple. Nope, 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 nope. Oh my goodness. This time we had absolutely none of them correct by using a spinner. So, if I remember correctly, the first simulation we had 3 correct. The second simulation we had only 1 correct. And in this last simulation we had 0 correct. So is this a good way to answer a 5-question multiple choice quiz? I'd say no, it's not, because we're not getting answers that closely match what we have here. So how could you answer this problem? You could say something like, no, this isn't a good way because when you use a spinner, that doesn't necessarily mean you're going to get correct answers, or something like that. Let's move on to problem 4. Samuel is taking pictures of the Spanish club, 5 officers. The club president will always stand on the left. The vice president will always stand on the right. How many different ways can we arrange the officers for the picture? Okay, so visualize what this looks like. In my mind, I see a dead pen. My pen's starting to die. In my mind, I see 5 slots, and according to the problem, the president is always over here, and the vice president is always over here on the right-hand side. This is problem 4, just a reminder. So we really don't have to do anything with the left and the right-hand slot. That really doesn't play into this problem. Even though there's 5 people involved in this, it's really only 3 people that we have to arrange. And the order matters, because we're trying to find all the different ways that we can arrange those people. Order matters. What does that sound like? Permutation. This is really a permutation of 3 people taken 3 at a time. Do you think you can solve that on your own? I'll let you figure that out for yourself. But you need to solve this problem to figure out how many different ways the remaining 3 people can be arranged into those 3 slots for the picture. Let's move on to problem 5. Lola purchased a $35 book bag at a sale price of $27.50. So the price went from $35 down to $27.50. And then it says, what was the percent of decrease from the original price to the sale price? Percent of decrease. Do you remember this formula? Percent of change equals the amount of change over the top of the original amount. That's what we're going to have to solve here. Percent of change equals amount of change over the original amount. Well, how much did this drop? Well, I'm going to have to take $35 minus $27.50 to find the amount of change, right? That changes to a 4 to make this a 10. Wait a minute. I can't take 4 minus 7. I've got to borrow from the 3. There's $7.50. So our amount of change is $7.50. Our original amount was the $35, right? And remember when we did these problems, I said think of this as being a ratio of x over 100. If you can find the value of x, you have found the percent of the change. Let's move on to number 6. Examine the bar graph. What is the probability that a student's favorite picnic game is sack racing? Well, remember that probability is the favorable outcomes over all of the outcomes. Probability equals favorable outcomes over all of the outcomes. What is favorable to the idea of sack racing? Well, looking at the chart, that number is 10. What are all of the outcomes? Well, aren't you going to have to add up volleyball, which is 13, card games, which is 7, sack racing, which is 10, softball, which is 11, and horseshoes, which is 9. And then it's very likely that once you get this fraction, you're going to have to simplify it to some extent. So going to have to add up all those numbers, put that number here because that's all of them, and then simplify what's left over. Okay, let's move on to number 7. Croquet is a lawn game. And the problem says 16 teams are going to be playing in a croquet tournament. If a team loses one game, it's eliminated. How many total games will be played in the tournament? Well, if there's 16 teams and one loss eliminates you, what I'm thinking is that this is kind of a situation where one's going to think about, oh, shall we say, kind of almost like a tree diagram in reverse. Team 1 has to play Team 2, Team 3 has to play Team 4, Team 5 will play Team 6. I'm wondering if we're going to run out of room here. I think we will. Maybe not. Maybe it'll stay on the screen. Is it? Nope, not quite. There it is. It's almost a tree diagram in reverse. The first game is going to be Team 1 versus Team 2, then Team 3 versus 4, then 5 versus 6, 7 versus 8, and so on down the line. And let's say, for example, that in this first game, Team 1 wins. We'll put Team 1 right there. But let's say in this game where 3 and 4 played, 4 wins. And we're just going to move down the way and assign different teams as either winning or losing each of the games and move our way down. How about, there we go. And then we got to keep going, don't we? And teams are going to be winning or losing games. Some teams will advance. Some will drop out because they've lost their first game. Maybe in this game, 1 versus 4, Team 4 won. Maybe here it was Team 5 that won. Maybe here Team 10 and down here Team 16. Then in this game between these two teams, let's have Team 5. And here Team 16 won. And finally the champion was Team 5. Well, I'm going to have to add up all the games that were played, because that's what the problem's asking you to do. Let's move on to the next problem. They're asking you to compare 1.38 times 10 to the 4th power to 29,000. And they're wondering, is Mauna Kea larger than Mount Everest, or is Mount Everest larger than Mauna Kea? Well, how do we do that? How do we compare something like this number to a number that looks like this? How do we compare 1.38 times 10 to the 4th to something like 29,000? Well, do you remember how to change scientific notation back into standard form? Let me show you an example of that. What if it said 2.56 times 10 to the 3rd? How do we change that? Well, this 3 means that the 10 is really 10 times 10 times 10. And what is 10 times 10 times 10? Isn't it 1,000? And what would 1,000 times 2.56 be? Well, if I did the math on that, 2.56 times 1,000, I would find out that I'd get an answer of 2,560 if I did the 3-digit times 4-digit multiplication. Now, another way to do this is to realize that multiplying by 10 to the 3rd is really moving the decimal point 3 places to the right. And moving it 3 places to the right gets you that number of 2,560. So, same thing up here. 10 to the 4th is really 10 times 10 times 10 times 10. And what is 10 times 10 times 10 times 10? 10 times 10 is 100, times 10 more is 1,000, times 10 more is 10,000. This is really the number 1.38 times 10,000. Now you can either multiply these two together, or you can realize that really what's happening here is we're moving the decimal point over 4 places to the right to change this into a standard form number. Once you do that, you can compare the two, and your answer is either going to be Mauna Kea or Mount Everest. You have to decide which of the two mountains is bigger. Okay, let's move on to the next problem. Each package of baseball cards contains a puzzle piece. If you collect all 6 puzzle pieces, you're going to win 2 tickets to a Major League Baseball game. There is an equally likely chance of getting a different puzzle piece each time. Explain how you would model this problem to find an answer. Explain how you would model this situation, right? Well, here's one thing that comes to mind. The problem with this is that you've got to find 6 different puzzle pieces by buying all this bubble gum, right? 6 different pieces. In problem number 3, we modeled that using a spinner, didn't we? Because the spinner had 4 sections and there were 4 problem answer choices that we could have. What if we used a die? A die has 6 faces. That could model the 6 different puzzle pieces. And from that, we could roll the die a number of times until each of the number faces showed up. And that would help us to think about how long it would take to buy enough of these puzzle pieces by buying the bubble gum. What do you need to do for number 9? You need to just simply explain that concept in a paragraph form. Number 10, the pattern below is known as Pascal's triangle. We talked about that before. Find the pattern and complete the 6th and 7th rows. Well, in the first row, they have a 1, don't they? In the second row, it's 1, 1. And in the third row, it's 1, 2, 1. And in the fourth row, it's 1, 3, 3, 1. And in the fourth row, it's 1, 4, 6, 4, 1. Is that all the farther they went? No, actually, that's the 5th row, isn't it? This is 5th, 4th, 3rd, 2nd, and 1st rows. Notice what's happening. It's always the numbers above that are added together to form the number below it. 1 plus 2 is that 3. 2 plus 1 is that 3. So to figure out the 6th and 7th rows, you always start with 1s on the outside, and then you just simply add the numbers that are above to create the numbers below. So this would be a 5, a 10, a 10, and a 5, right? Now I just did the 6th row for you, but you're going to have to come up with the 7th row on your own. Okay? Number 11, a 21 kilogram sample of rock is about 40% oxygen and about 19% silicone. How much more is the oxygen mass of the rocks than the silicone mass? Well, to me, this sounds like 2 separate problems. And notice, I'm pretty sure that you can estimate on this problem, because notice they have the word about in this problem, about. So I would be thinking about 2 things. What is 40% of 21 kilograms? And I'd be thinking about what's 19% of 21 kilograms. Why would I be thinking of those 2 things? Well, because we're trying to figure out how much more oxygen is in these samples than silicone, right? 40% of, isn't that really 0.4 times 21 of is multiplication? And this right here is 0.19 times 21. And when we get these numbers here and here, well, we can estimate, right? 21 times 0.4, I get 4 and 8, 1 decimal place, so I get 8.4. And 0.19 times 21, I'm going to let you do the rest, right? but you're going to have to take this number and the number you find here and subtract them, because the problem's asking you how much more is the oxygen mass. This is the oxygen mass, 8.4 kilograms. How much more is this than the amount of kilograms you're going to get for this slot? Okay? Let's jump down to 12. I'm going to let's just read through it. A taxi charges $2.35 for the first 4/10 of a mile, and then 75 cents for each additional 4/10 of a mile. Find the cost of a 4-mile taxi ride. Well, imagine that this is the 4 miles that they're talking about, 4 miles. And we want the cost of that ride, right? This would be 2 miles, right? This would be 1 mile. This would be 3 miles. And this would be 4 miles, right? Let's divide this up into 0.4 chunks, right? 0.4 chunks. How do we do that? Well, we know that if I were to divide this in half from here to here, this would be 0.5, wouldn't it? And right here would be 1.5 miles, right here would be 2.5 miles, and right here would be 3.5 miles, right? How many 0.4 chunks are there in 4 miles? Because that's important to this problem. We need to take the 4 miles and divide by 0.4 chunks, right? Now, we can't really do this with a decimal point in the denominator. I'm sorry, not denominator, but dividend. So we move the decimal point over once, and when we do that, we got to do that once for this as well. And so there is 10 of these 0.4 mile sections. There are 10 of these 0.4 mile sections from here to here. Because the first one would be right here, and the second one would be right here, third one would be right here, fourth one here, fifth one, and sixth one, seventh one, eighth one, ninth one, 10th one. So the very first one, according to the problem, costs how much money? Well, that first one costs $2.35. And the remaining 9 of them are 75 cents a piece, right? So there's 9 groups of 75 cents there, and that would be $6.75. So the first 0.4 chunk of mileage is this amount. The remaining 9 sections is this amount. How do you figure out the total? I'll let you proceed from there. Number 13. It says in a middle school of 900 students, about how many of them prefer the season of autumn? Well, autumn is 31%, right? 31%. And notice they do use the word about in the problem. So really we could write it this way. What number is about 31% of the 900 total students? What number is about 31%? I would change this to 30% times 900. Remember, change this to a decimal number before you multiply these two together, and that should give you your answer. Because remember, the word is our equal sign, and what number is our variable. Okay, I hope this helps you. Thank you, and have a good day. Give me a call if you're stuck.